Mallikarjun sir. Good morning, all of you. Can you hear me?
Yes, sir.
Yeah. Last week we discussed about all the e-resources subscription and the e-resource types and what kind of subscription models are available. And now we'll go to the bibliometrics. Before patent and standards, we'll go to the bibliometrics and to bibliometrics to all metrics. This is one by one we'll discuss.
Good morning, sir.
Morning, good morning, all of you.
Sir, your voice is not clear, sir.
Okay.
Increase your volume, sir, please.
1 minute. Can you hear me now? Can you hear me?
Yes, sir.
Yeah.
Very low.
Low means this is the computer inbuilt. I cannot do anything here. Okay. This is not a phone also. 1 minute. I will check with other options. Now it is okay. Can you hear me? Hello.
Sir, clear gaane undi, sir.
Okay. Maybe they need to increase their own system volume. Maybe it is from my side, it is okay. Everything is okay. Okay. Yeah. As per last week discussion, what are the topics, main topics we discussed? Once again, we'll go through. Okay. From block 1, scientific information, science information system, publishing. That's a introductory chapter I already told you. Please go through. That is a basic one. And in block 2, e-resources, we discussed in detail what is an e-book, types of e-books, e-journals, electronic databases, right? These 3 units overall we covered. We'll come back, reports, patents, and standards. These 3 portions then we'll cover tomorrow, okay? Reports, patent, and standards. Then comes to the block 3, metrics and citations, bibliometrics and citations. Bibliometrics to all metrics, citation indexes. Today we are going to detail about bibliometrics to all metrics. Okay. One thing I would like to know, how we'll measure that, how many books are issued, how many books are consulted, read, how many books we issued. These are the statistics day-to-day library environment. When it comes to the electronic environment, usage statistics, bibliometrics, citation, and cyanometrics, all metrics, these are all the analytics. Okay. E-resource analytics. Analytics means calculations. Okay. See, generally, electronic resources having its own analytical methods. Okay. What it is, bibliometrics, what it is. Okay. A study which seeks to quantify process of written communication. See, written communication to quantify how many times it is cited, how many times it is downloaded, how many times it is viewed in social networking site. These are the quantifying the articles, especially it is article. One more, this is a definition by Pitchcart. The quantitative treatment of proprietarized of recorded discourse and behavior pertaining to it. Okay. This is another kind of definition. And one more definition, recorded communication of literature. Okay, this is a quantitative method. Okay, and if it comes to the actually who coined this term, bibliometrics, who coined this term? Alan Pritchard in 1969 coined this bibliometrics, the application of mathematics, the statistical methods to books and other media of communication. Okay, it is quoted in Journal of Documentation 1969, volume number 25, issue number 4, page number 348, 349. This is a definition is coined by Alan Pritchard, 1969. Okay, the application of somebody's switch off your mic. Who is the yes? See, you
Okay,
need
sir. Okay.
yeah, switch off your mic. Whenever you need, then you need to unmute and you call. Okay. The application of mathematics and statistical methods to books and other media communication. It's called as bibliometric. Okay. When it comes to the metrics, also we use study broader than books, articles. So sometimes maybe it is a scientometrics covering science in general, not in just publication. Infometrics, all information objects. Okay, these are the different terminologies they used for bibliometrics. Scientometrics, infometrics, scientometrics covering science in general, not in just publications. Infometrics, all information objects, including articles, standards, patents, books, everything. Then one more terminology we frequently hearing in a library and information science literature, web metrics, cybermetrics. Web metrics, web connections are manifestations. Okay. Using bibliometric techniques to study the relationship or properties of different sites on the web. That is web metrics, or it called as cybermetrics. See, both are similar words. Okay, both are substitute. They are using web metrics and cybermetrics. Using bibliometric techniques to study the relationship or properties of different sites on the web. Okay. These are the terminology we are discussing now, and in detail I will go one by one. The basic concept in bibliometrics, first of all, is a subject. What subject we are handling, and recorded communication, document, information object. Document means book, article, whatever it is. Information object. Okay. Subject literature, bibliometrics related to science of science. We can call it as science of bibliometrics related to science of science. Sociology of science, numerical methods. These are all the numerical methods. Okay, when it comes to the literature study, the qualitative, sometimes maybe qualitative, sometimes maybe quantitative. When it comes to the quantitative, bibliometrics is the first method to measure it. So after humanities and librarianship, say qualitative, how we measure how many times it is cited, how many times it is downloaded, how many times it's read, how many times it's mentioned in social networking site. Okay. And reasons for quantitative study of literature. What are the reasons? Why we need to study quantitatively? Why we need to study quantitatively? Okay. See, why we need to do quantitatively? Can you tell me anybody? ఎందుకు మనం క్వాంటిటేటివ్ గా స్టడీ చేయాలి పబ్లికేషన్స్ ని? ఓకే, ఎందుకు మనం క్వాంటిటేటివ్ గా స్టడీ చేయాలి? Anybody can explain? What are
Because
the
there will be a number of words, sir.
No. See, bibliometrics అని అంటున్నాము. Bibliometrics అంటే it is a quantitative ga, how many times it is downloaded, how many times it is cited, like that, right? See, why we need to study? Why we need to study? Reasons for quantitative study for a literature. Literature ante it's not a literature, it is a information. So different subject area information. For example, in a physics, how many publications are available from so-and-so to so-and-so, particularly in India, particularly in IITs, how many publications are available? How many publications published by the faculties? We are quantifying how many publications are published by the Department of Physics from IITs, all IITs. Then these publications, if you quantify, okay, some number, one number, say 1,000 articles are published. How many times it is cited? Which article is cited more? Which article is downloaded more? Means once it is downloaded more, it is having a quality also, right? See, ఏదైనా ఎక్కువగా డౌన్లోడ్ అవుతుందంటే ఎక్కువ యూజ్ చేస్తున్నారని, ఆ పర్టికులర్ ఆర్టికల్ ఎక్కువ యూజ్ చేస్తున్నారు లేదా సైట్ చేస్తున్నారు, మళ్ళీ వేరే రీసెర్చ్ పర్పస్ కోసం సేమ్ పబ్లికేషన్ దే రీయూజ్ ఇట్. ఓకే, reasons I can analysis of structure and dynamics. Okay, search for regularities, prediction possible. Okay, understanding of the pattern. See, ఏ method లో publications publish అవుతున్నాయి. See, every year same quantity of number publish అవుతున్నాయా IITs నుంచి, particular physics department 1000 articles publish అవుతున్నాయా, less it's come down next year. From if you take the 2010 to 2020, 2010 is 500, 2011 is 600, 700, like that. Every year it is increasing 10. If you take example, then it is every year it is increasing 10%. Say 10%. We can study that how publication pattern is moving. Okay, order out of the documentary choice. Verification of models, assumptions, rationale for policies and design. Why we need to quantify, rationale for policies design. See, next year we want to give some faculty promotion, CAS, okay, advanced career advance scheme. In career advance scheme, we need to quantify and quantitatively, qualitatively, we need to check what kind of publications are going in a department. Then we need to verify the data. See how many publications are published over a period of time. Then how it is cited, what is the H index, citation H index. Okay, these are the metrics we are using. Okay, these are the reasons. Why quantitative studies? Why not qualitative? Why quantitative? Qualitative methods often depends upon assertions, authoritative statements. Okay, science searches for regularities. Okay, success of statistical method in social sciences, need for justification. Okay, basis for a decision. Something can be counted. Okay, why we need to quantitative studies means these qualitative methods often depends on assertion, authoritative. In a quantitative method, science searches for regularities, success of statistical method in social sciences. These are the techniques we are using, statistical methods we are using, quantify the publication pattern. Okay. See, applications sometimes maybe in sociology, science, different areas, these bibliometric studies are using. Bibliometrics, it is historically, if you see these bibliometric studies, it is having a lot of influence in qualitative study. Bibliometric methods, such bibliometric application in a different science, sociology, and humanities. Lot of impact is there. Okay, if it comes to your course syllabus, okay, in our page number 105 and 106 and 107, they given different definitions, bibliometric definitions. Okay, in this I would like to emphasize Lancaster. According to the British Standard Institution, bibliometric is the study of the use of documents and pattern of publication in which mathematical and statistical methods have been applied. Okay, the application of various statistical analyses to study patterns of authorship, publication, and literature use. Okay, and the application of various statistical analyses, okay, authorship kaavachu, publication kaavachu, then literature use, how many times it is downloaded, how many times it is cited, how many times it's mentioned in social networking sites, Twitter lo annisarli article share cheskobaddadi, how many times it's shared in WhatsApp and different social media. See, it means that the value of the publication, it is going to be reflected based on the quantify. Okay. Qualitative analysis of literature of the subject domains is represented by bibliographical entities such as keyword, classification codes, authors, and citations. This is Willett definition. So here, and Nicholas Rettelay mentioned sorry, I need to take one call, okay? Actually, in a bibliometric analysis, quantifying a bibliometric analysis, some more points is mentioned in Nicholas in his bibliometric study. Bibliometrics provide information about the structure of knowledge and how it is communicated. For example, authors are corporate body, forms of transmission, journals, monographs, etc. Medium of communication wise articles or letters, book chapters, whatever it may be. Nature of information conveyed, that is how much literature exists in various languages and subject areas. Timing and frequency, which is informed, is conveyed. Amount of information conveyed by various individuals, group, organization, countries. Geographical distribution of the document. Citations next, the most cited authors are articles, journals, institution, disciplines, subject distribution helps the assess the subject, those are becoming obsolete. Means, for example, ఒక సబ్జెక్ట్ ఎక్కువసారి డౌన్లోడ్ చేసి సైట్ చేయబడుతుందంటే ఇట్స్ మీన్స్ that subject is going to be in a trend. See, which subject is not used, not downloaded, not, so it's kind of one kind of, its subject is very less used. In this way, they have different kind of treatments as historical perspectives. So many historical perspectives given in the study material. And next comes to the bibliometric laws. What are the bibliometric laws are available? Okay. What more? See, in a bibliometrics, sometimes maybe what context, or text, part of text, subject, classes also, it's going to be included in the bibliometrics. See, representation maybe it's a citation to the document, in a document, or co-citation, circulation, various users, links. These are the additional points. Okay. When it comes to the what are the laws, bibliometric laws are available. Okay. I will give one by one. Okay. See, one is Lokta's inverse square law. So it is given in our study material 109, page number 109. Okay. These are the different kind of bibliometric laws. One is Lokta's law and Bradford's law scattering and Gibbs law of term distribution and modern bibliometric studies, little science, big science. Okay. And bibliometrics, its applications and limitations. Okay. Then it comes to the advancement of the bibliometrics, cyanometrics, webometrics, cybermetrics. There are the now some of the people, they are using the informatics. Okay. Then webometrics, cybermetrics is webometrics, cybermetrics. These are the additional kind of metric statistical methods used in bibliometrics. And now we call it as all metrics also. All metrics is another kind of advancement in the bibliometric study. Okay, we'll go one by one. Okay. As of now, any doubt regarding the basics of bibliometric study? If there are doubts, just let me know. Doubts unnaya meeku evana? Can you hear me? Vinipistunda?
Yes, sir.
Cheppandi. Evana doubts bibliometrics? See, maybe this topic bibliometrics is a little bit technically, it is a very, technically speaking, it's a very tough subject when compared with other chapters, previous chapters. It is application of statistics and mathematics. I'm not going in depth, just basic level only. I'm understanding. Okay. You understand, no? Only basic level. What are the methods and how we are studying, what are the content it's going to cover, why we need to study. Okay. When it comes to the bibliometrics laws, we'll go by one. Okay. So I think you don't have any doubt. Okay. Then it comes to the bibliometric definitions, no? Laws, bibliometric laws. Lokta's inverse square law. See, Alfred J. Lokta is a pioneer in bibliometric studies. In 1926, Lokta's published a study on the frequency of distribution of scientific productivity. The frequency distribution of scientific productivity determined from the decennial indexing. See, 1907, 1916. This is defined by the Alfred J. Lokta. This law is called Lokta's inverse square law. Okay. Lokta's law describes the frequency of publication by the authors in a given field. He proposed an inverse square law relating to scientific papers to the number of contributions made by each other. Okay. This is the main core area of the Lokta's law. Once again, I will read it. Lokta's law describes the frequency of publication by authors in a given field. Okay, particular field, frequency means Lokta's law is describe the frequency of publication. Frequency of publication, how many times cited in a particular subject area. He proposed inverse square law relating to scientific papers to the number of contribution made by each other. Okay. Proportionate. Okay. The number of authors is given in the field. The frequency of publication is given in the below. Meeku table number, మీ దగ్గర book unte, course material book unte, page number 109. Page number 109. Okay. Authors percentage, number of publication. See, they given in a tabular form. If you understand that, okay, Loktas equation is x power of n, sorry.
Sir, number of publications means how many times it is published, sir?
How many times is published kandi? For example, oka author publish చేసినటువంటి article how many times is circulated? It means cite ayindi.
How many times it is cited?
Yeah, it is very frequent. Once again, I will read it. In Loktas law, describing the frequency of publication. Frequency means how many times it is cited. For example, మీరు ఒక ఆర్టికల్ రాశారు, ఆ ఆర్టికల్ ని వేరే ఆథర్స్ how many times it's cited, how many places, కదా? This is how many times. That's what they given in a author's percentage and number of publication. See, table చూస్తే మీకు అర్థమవుతుంది. Okay. Then where is the x is the number of publication, y is the relative frequency of authors with x publication, and n and c are the constants depending on which specified field constants anamata, n and c. The value of the c was found in the 0.6079. See, if you see this example, ఎందుకంటే నాకు ఇక్కడ బ్లాక్ బోర్డ్ లేదు, see, otherwise I can put it in a format. బ్లాక్ బోర్డ్ ఉంటే మనకు దీన్ని ఒక ఎగ్జాంపుల్ తీసుకుని కూడా చెప్పొచ్చు. కాబట్టి you need to, it's a very simple calculation. This is the page number 109. If you go through, then you can understand. Okay, once comes to the Bradford's law of scattering. Actually, this Bradford's law is a popular one when compared with the Loktas law. So Bradford's law is a scattering, they call it as a scattering law. Okay, Samuel Clement Bradford published a study on the frequency distribution of papers over journals in 1934. According to his study, the journals in a single field could be categorized into core journals on the subject, second zone and third zone. Each zone observed to contain the same number of articles. The core journals, first zone, are lesser in the number, but the processed almost all 1/3 of all the articles. The second zone, through the containing the same number of articles, but belongs to more number of journals. Similarly, in third zone. See, this is a little bit difficult. That is the reason, please open the page number 110. 110. అక్కడ మీకు ఒక టేబులర్ కాలం ఇచ్చారు. అంటే ఇక్కడ సబ్జెక్ట్ ని they make it as a groups, zones, zone 1, zone 2, zone 3. Each zone is containing a journals or titles, number of journal titles. In a Web of Science, they call it as Q1, Q2, Q3, like that. See, same way, they made it in a subject area. For example, in mathematics law, 3 zones ga divide chesaru. Zone 1, zone 2, zone 3. In the zone 1 లో ఎన్ని జర్నల్స్ ఉన్నాయి, ఆ జోన్ 1 లో ఎన్ని పబ్లికేషన్స్ పబ్లిష్ అయ్యాయి, దాన్ని బట్టి ఈ ఫార్ములా అప్లై చేయబడుతుంది. ఓకే, ఓపెన్ చేశారా పేజ్ నంబర్ 110?
Yes, sir.
110లో మీకు జోను, నంబర్ ఆఫ్ టైటిల్స్, నంబర్ ఆఫ్ పేపర్స్ ఉన్నాయి. ఓకే, జోన్ 1 లో ఎన్ని జర్నల్ టైటిల్స్ ఉన్నాయి? 9 ఉన్నాయి. నంబర్ ఆఫ్ పేపర్స్ 429. జోన్ 2 లో 59 టైటిల్స్ ఉన్నాయి, but 499 పేపర్స్. ఈవెన్ లెస్ నంబర్ ఆఫ్ జర్నల్ టైటిల్స్ లో కూడా ఎక్కువ పేపర్స్ ఉన్నాయి, because it is qualitatively we can say more. In the next zone 2, 59 journals, but 499 publications only. Okay, if you go to the zone 3, 258 journal titles వేరు, articles వేరు, number of papers వేరు. You need to differentiate. Okay, అర్థమైంది? ఇక్కడ జర్నల్ టైటిల్స్ అంటే నంబర్ ఆఫ్ జర్నల్ ఆర్టికల్స్ దాంట్లో పబ్లిష్ అవుతుంటాయి. ఇక్కడ జర్నల్స్ టైటిల్స్ జోన్ 3 లో 258 and number of papers is 404 when compared with zone 1 is less than that. Total number of journals 326, total number of publication 1332. This, it is understand 9 journals in the core zone contributed 1/3 of the article. అంటే ఫస్ట్ జోన్ లో ఎక్కువ కాంట్రిబ్యూషన్ ఉంది, సెకండ్ జోన్ లో తక్కువ ఉంది, థర్డ్ జోన్ లో ఆర్టికల్స్ కాంట్రిబ్యూషన్ ఎక్కువ ఉంది, జర్నల్స్ ఎక్కువ ఉన్నాయి. ఓకే, 5 times more in second zone. In third zone is approximately more than 5 times to the 9. The broad force laws were popular, helped in the libraries for determining the number of core journals in the given field for library subscription renewal, especially during the budget crisis. అర్థమైంది కదా? మనం బ్రాడ్ఫోర్డ్స్ లా ఎప్పుడు అప్లై చేయాలంటే whenever you need budget prioritization, any budget prioritization, which journals we need to subscribe. Whether, see, for example, zone 1 we need to go for a subscription, zone 2 we need to go for a subscription, zone 3. See, because zone 1 number of journals are very less, number of publications are more, then more content with a less price, then we prioritize, we need to go for a zone 1 by very, very simple logic. If there is any specific requirement, is there any specific demand from the user point of view, then there is a chance for a go for different zones. This is the one way it is going to be helpful in budgetary prioritization in library purchase models. Okay. ఇది ఏదైనా అర్థమైందా మీకు? అర్థం కాలేదు ఇంకోసారి ఎక్స్ప్లెయిన్ చేస్తాను. Once again I am going to explain.
Sir, once again, sir.
అదే, see, you need to understand zones first of all. Okay, they divided subject area into 3 zones. This is the imaginary zones. Don't think that this is going to be commonly applied for each and every field. They take an example. Okay, see, mathematical relationship of number of journals in one core in the sense zone 1, zone 2, zone 3. They divided into subject area in 3 zones. In a zone 1, number of journals 9, number of paper published in 429. In zone 2, 59 journals, number of papers 499. In zone 3, number of journal titles 258, number of papers 404. You got it? This relationship we need to understand first. Zone 1 lo 9 journals ఉన్నాయి, number of papers 429 ఉన్నాయి. Zone 2 లో అంతకన్నా ఎక్కువ జర్నల్స్ ఉన్నాయి, 59 journals, but number of publications more or less similar. But how many times is more in zone 2? 5 times. Okay.
సార్,
చెప్పండి.
ఇందులో నెంబర్ ఆఫ్ టైటిల్స్ 9 ఉన్నాయి కదండి సార్. ఇందులో పేపర్స్ 429 ఉన్నాయి. సెకండ్ వచ్చేసి 59 ఉన్నాయి కదా సార్ టైటిల్స్. ఓన్లీ 499 ఉన్నాయి సార్ పేపర్స్.
That's what. See, sometimes what happens, no, in some of the journals they don't want to submit because the impact factor, number of reasons, whatever reason it is. See, we are studying that publication pattern. How publish outunnayi particular journals. 59 journal titles lo 499 అంటే తక్కువ పబ్లిష్ అవుతున్నాయి ప్రపోర్షనేట్ గా జోన్ 1 తో కంపేర్ చేసుకుంటే. That's what we are studying. See,
అంటే ఓన్లీ పబ్లిష్ అయినవేనా సార్ 499?
పబ్లిష్ అవ్వబోయే కాదు, పబ్లిష్ అయినవి. ఇప్పుడు ఓవర్ ఎ పీరియడ్ ఆఫ్ టైం 2020 లో 59 జర్నల్స్ లో 499 ఆర్టికల్స్ మాత్రం పబ్లిష్ అయ్యాయి. పైన జోన్ 1 తీసుకుంటే ఓన్లీ 9 జర్నల్ టైటిల్స్ లో 429 పేపర్స్, మోర్ పేపర్స్ ఆర్ పబ్లిష్డ్. మీన్స్ కంటెంట్ ఎక్కువ పబ్లిష్ అవుతుంది. ఓకే, then we can prioritize when we have a budget crunch. Budget crunch ఉన్నప్పుడు which one, which zone, which journal title we need to subscribe. This is going to be helpful decision making. So decision making lo ee law is going to be helpful. That's what I am telling. Okay, right?
Okay sir.
Next,
మనం ఇవన్నీ ఈ ఫార్ములాని బట్టి చేసుకోవాలా సార్?
ఆ ఫార్ములా మీకు అప్లై చేస్తే మీకు నంబర్ ఆఫ్ జోన్స్ మీకు డివైడ్ చేసుకుని, ఫర్ ఎగ్జాంపుల్ ఇది నౌ వి క్యాలిటైజ్ ఇన్ మ్యాథమెటిక్స్ లో మనం అప్లై చేసాము ఈ రూలు, లేదా సోషల్ సైన్సెస్ లో ఎన్ని జర్నల్స్ ఉన్నాయి. ఓకే, యూ categorize zone 1, zone 2, zone 3 like that. See, for example, if you are working in a medical college library, how many journals are we are subscribing? You categorize how many journal articles are published in particular journal. Okay, how many journal article published in each and see, you make an Excel sheet, journal title, how many journal articles are published, each journal wise. Then you make it A to Z, which is most published article. Then you make it a zone, which is comes under zone 1. You take a 5 journals. Zone 2, like that you divide it in a subject area. మీరు ఆల్రెడీ సబ్స్క్రైబ్ చేస్తున్నారు. ఫర్ ఎగ్జాంపుల్ మెడికల్ సైన్సెస్లో మెడికల్ కాలేజ్ లైబ్రరీ మీరు వర్క్ చేస్తున్నారు అనుకోండి. ఫర్ ఎగ్జాంపుల్, how many journals are subscribed? 100 journals you subscribed for the medical college library. You collect the data, how many journal article published from the each journal. You make an Excel sheet. You make it A to Z, divide into zones, and you calculate this applications. ఈ ఫార్ములా అప్లై చేసి మీరు క్యాలిక్యులేట్ చేయొచ్చు, విచ్ ఈస్ మోస్ట్ క్వాలిటేటివ్ క్వాంటిటేటివ్ జర్నల్స్ అని. అర్థమైంది కదా? Yeah, next to Gibbs law, term distribution. George Kingsley Gibbs, 1935, studied the frequency of words within the large amount of text. His law exhibits the relationship existing between frequency in use of the words and their distribution in books, reports, documents, in other printed matter. Ante ikkada oka particular keyword, for example, nanotechnology, nanotubes ane oka word తీసుకుంటే how many times it is occurred or available in a publications. Article lo nanotubes kani nanotechnology ane rendu terminology manam select chesukunnattu. For example, how many times it is visible occurred in a different publications. That way it is going to calculate. It is purely digital environment lo maatrame sadhyamavutundi. Print environment lo it's highly impossible. Okay, it's applied in digital environment. See, print environment lante every time manually we need to calculate. It is how much it is difficult it is. Yeah, they given a formula also. It is a very simple formula. No need to worry. You can understand very easily. Okay, Gibbs law is weak, and then it. వినిపిస్తుందా? Can you hear me?
వినిపిస్తుంది సార్.
వినిపిస్తుంది సార్.
Then modern bibliometric studies లో little science, big science. This is a one kind of this is the scientific communication theory by the Dr.C.Mallikarjuna Prize. His book entitled Little Science and Big Science in 1963. Okay, what it describes, I'm going to point by point, I'm going to explain. Price described that 1980, 80 to 90% of important scientific works has occurred in one normal human lifespan. He stated that transition from the little science to big science was gradually, especially in the social, economic, and the methodological sense, science in the 21st century. Second parallel, the measure of the size of the science are number of publications double in every 10 to 15 years. This is the major core area of the theory. In this, say, price is one factor. Then the second factor is the measures of the science or number of publication doubles in every 10 to 15 years anede ee oka principle oka major contribution. Okay, if you this rate the expansion is considered broadly, then from the 16th century to until now, such size is measured science have increased by the factor of 10 to the power of 6. 10 to the power of 6. From this observation, Price described coefficient of immediacy, a ratio of percentage 7.7:8 and 87.5% respectively. Okay, this is very ikkada meeku board unte tappa nenu explain cheyalenu. But that is the reason you go through this, okay? This we need to take an example, then only we can understand this principle, okay? You need to understand that measure of the science, number of publication doubles in every 10 to 15 years. Idi matram meer artham cheskondi. If there are any examples needed, then this you need to apply. Page number 111, page number 111 లో మీకు ఇచ్చిన ఎగ్జాంపుల్స్ మీరు యాజ్ ఇట్ ఈస్ గా అప్లై చేసుకోవచ్చు. ఓకే, then what are the limitations? Bibliometric applications and limitations. Bibliometric applications లో ఉండేటువంటి limitations ఏంటి? The bibliometric studies lead to the formulation of laws, theories, and some of the practical application in literature's research and analysis, library management, and decision making. Okay, bibliometrics provide information about the structure of the knowledge, communication, pattern, indicating the size and trend of literature growth, subject scattering, productivity of the authors. Okay, it is purely analytical way they are analyzing, but how much is important of particular publication? Qualitatively measuring is very poor. అంటే క్వాలిటేటివ్ మెజర్ చేయడంలో బిబ్లియోమెట్రిక్స్ అంత ఎఫెక్టివ్ గా పని చేయట్లేదు. యు అండర్స్టాండ్? దట్ ఈస్ వాట్ లిమిటేషన్. Bibliometric is helpful in quantitative assessment of core journals and watershed of publication specific discipline. Particular discipline లోను క్వాంటిటేటివ్ గా స్టడీ చేయడానికి హెల్ప్ అవుతుంది, కానీ క్వాలిటేటివ్ లో మెజర్ చేయడం ఇట్స్ వెరీ పూర్. ఓకే, in case of growth of different areas of knowledge, project, the development as well as the declining area of literature over a period of time, the measure usefulness of information services. These are the limitations. Okay, you understand, no? These are the limitations. Then I will give one example, Bradford law scattering zone. I am going to present one video, just 2 minutes.
the information seeking, the topic analysis thing, and to help with all of those promotion or so when you submit your manuscript to a journal.
Yeah, I'm giving one example how they analyzed publication bibliographical data, National Institute of Health. Okay, this is one example I would like to show just to go through.
No, you're going to submit even more. You're going to submit your affiliation. You can get what kind of a list to pull out any different. You can also look at authorship. So by authorship, generally we look at two things. One is collaboration, okay? The other is contribution. So for collaboration, we look at who worked on these research together. And we can look at different levels, individual authors, their affiliations, and maybe if the research is funded, we can look at the co-funding agency. So there are a lot of different levels that you can look at. Sometimes you may also want to look at the country, especially for public health. Okay, they wanted to know specific countries work together on the topic. And for the contribution, they wanted to look at the author by line, like who is the first or last author. Generally, they think that they are more important. They also wanted to see that if there's any gender difference, things like that. Okay, for a research topic, there are a lot of different ways people can look at that. We can look at a subject category assigned by the vendor databases. We can look at the words in your titles or abstracts. Okay, we can look at some control language, vocabulary language, such as the mesh terms. Okay, and we can also look at the cited reference at the end to look at how similar they are, and then pull out specific grouping and topic from that cited references. And we can also look at specific tricks, and we have to understand the limitation or the. We can also create a map.
Yeah, this is a bibliometrical application. See how we can apply this.
Or the top countries that work on these kind of research. And there are times people even wanted to know more about specific income level. Are the research being produced by high income countries? These two authors. Okay, so you can see that Schusterman is the one that produced a lot, and he works a lot with all of these authors. There are different groups here, and they also have different interactions. But there is someone in the middle, this author, Leo. Okay, that connects the two clusters. If we just pull out a whole list of the names, it probably wouldn't be the top 10 or top 20. Okay, just look at the font. He wouldn't be one of the major top authors. We also like to see what kind of institutions
this is the author map
here. So you can see that for US CDC here, we work a lot with WHO. For the Chinese CDC, they actually work a lot with other Chinese, the public health part. But there are no lines connecting these two agencies, meaning that they do not co-fund any of the Ebola projects. It is interesting to us because we wonder, why is it so? Do they really fund API able to get it?
Yeah, subject determine how many times this subject is
so you can get these categories easily from vendor databases, and I'll be talking about that in 2 weeks when we talk about the use of Web of Science and Scopus to get all of these things. But the major complaint was that these categories can be very broad. Just imagine the 22 disciplines in Scopus. Okay, so we do a lot is to look at the similarity of the cited references in the back. So the theory behind it is that Chris and I published 2 different articles, okay? And we both cite something in the end, at the end of our articles, right? So we pull out our references and to see how similar.
This is another kind of application, subject-wise, how many times it's published.
That actually the research find or provide
pediatrics, cell biology, subject-wise.
To really support their change. Okay. The last thing that people are interested in, or things that we do a lot, is about the citation impact. Okay, so here in our team, we usually use
why I am showing this slide presentation, just to go through, you can understand practically how we are applying this bibliometrical study in a different subject areas. So this is presented by National Institute of Health, NIH Library, our subject publications with their database, Citation Impact. This is the next chapter in your course material. Another 5 to 10 minutes, I'm going to present this slide, okay?
Percentile rank. And I'll talk about why we use percentile rank instead of other things later in the week. Okay, so here you can see that we look at how many papers are being ranked at the top one in terms of the citations they received in this particular area and the year the publication appeared. How many publications are being ranked at the top 10, top 20, top 50, top below 50, things like that. And these things are, you can actually have your own grouping. If you want top 5, top 15, you can do that as well. We have the tools and software to do it. It's also a very easy way for us to compare publications from different disciplines, different offices, different programs. A lot of times it's not easy for us to compare because the way citations accumulate.
Yeah, we studied zone 1, zone 2, zone 3 like that. They made it as a tier 1, tier 2, tier 3. That is a difference.
Rates. They have different publication rates. So percentile ranks actually provide us a much better or easier way to give us the context to understand the publication. And again, I'm going to talk more later in the week. So this is just to show you that what has been done and why we're doing this. Okay, and remember, people ask about what are some other impact that we can use. So here we look at how many guidelines or patents cited specific research. So these are some other programs that I don't want to name. Okay, but you can see that they have a lot of guidelines that cite their research, a lot of patents that cite their research. So we can also use that as a way to say that we have provided kind of an impact to research. Okay, and as I said that we saw so many numbers in bibliometrics and we can provide tons of numbers as well. So usually we just give them a suite of numbers, okay? So that people can see that there are a lot of things they can use to describe their research. We can look at the publication count, the citation count, what is the mean or the median, the self-citation rate, their portfolio H index, the RCR that is developed in NIH, also the top 10% citations or so patents, guidelines, things like that. You can provide a long list. You can provide numerous indicators, okay? But you want to make sure that they give meaning to the research. Okay, all right. So in brief, bibliometrics can do a lot of things. They can quantify, right? Give a lot of numbers. They can visualize a lot of things, okay? Starting maybe from the very beginning to see how it grows and to the current status, okay? They can also identify a pattern or problem. They remember the one we talked about, the Ebola research, talking about the co-funding thing, okay? They help us identify a problem. And they also help us to present impact. Okay, so this is about the animal research and how we can show the impact of animal research. We compare it with other research and see that when publications have to do with both human and animal subjects, it actually has the highest citation count and also has the highest rate of highly cited papers. Okay, so just some example to see what bibliometrics can do. All right, it sounds like bibliometrics kind of like magic, can do a lot of things, right? Yeah, but no, it has limitations, a lot of limitations actually. Okay, so just like when we do any analysis, we're going to have input, right? We put something in, we have to process it, and then there's output. kind of like cooking or baking. You have your input, you have process, you have your output. Okay, but then we have to think about what do we put in? What's the process? What is the output? The ideal case is that we have the great input, great ingredients, great process, okay? And we have the great output, the best cake or bread that you have ever made. Okay, that's the best scenario. Okay, but there are times that you just can't get that the right ingredient. Okay, something is wrong. Okay, and then your oven is not working, or it's too hot, it's too cold. Okay, you have to do something to make the process right. And you still want to have the better output. Okay, but there are times you just have junk in and then garbage out. And that's the thing that you don't want to have. Okay, so there are a lot of limitations and restrictions and a lot of concerns. So for input, for example, we want to consider the data availability. Okay, what is available? So remember, when we submit something, we are looking at the publications only, right? And when we submit our manuscript for journal, we give them our name, our affiliation, our article, and maybe some keywords that we assigned. Okay, that's the thing that we give. It's actually quite limited. But once it is in the hands of the publisher in the journal, they can actually give a lot more things, right? They will give, if it is being accepted, they're going to give you some specific number, a session number, or maybe the PMID number. They have their own classification system. They're going to be assigned to some specific subject category. Okay, you're going to get a journal title, okay? And then once you have that, they're going to link you to a lot of different things. But it also has to do with the database or the vendor scope. If I'm from Scopus, okay?
Yeah, here I would like to show one example from Scopus, okay? Just 1 minute. Can you see this? How many publications? This is a bibliometrical application, bibliometrical study application. See where they applied. It's see in physics and astronomy, these many publications, engineering, biochemistry, computer science, material science. How much percentage total publication from MIT over a period of time? Okay. This is the one kind of analysis. Okay, statistical analysis. See, these are the advantages bibliometrical applications. See, we can observe that how much percentage physics and astronomy, which is the highest percentage of publication, which department, which area of discipline. Okay, this is multidisciplinary. Majority of the social science, neuroscience is multidisciplinary. This is engineering, 14.8%. This is biochemistry, genetics, and molecular biology. Okay, this is computer science, 7.8%. This is the application of bibliometrics in real time. Okay, if you make it as a document count, this is high to low, low to high. Okay, this also we can filter it out. Yeah, for example, if material science, if you click on the material science, okay, how many year-wise, what is the publication count. 2022, 47 documents. In 2021, 1,261. So if you see this, every year, an average 1,200 articles are published. We can understand growth of the publication. We can understand growth from 2013 to 2022. 13 is the 1,140. In 2020-21, 1,261. Don't calculate this one 2022. Why? Because it's the beginning. In the month of January, we are counting this 47. See, 47 into 12, maybe more or less approximately yeah, it is not representing. Means maybe sometimes March, in the month of March, they will publish 100 articles. We don't know. That is the reason. This we cannot consider 2022 and 2021, 2020, and remaining years. If you see this, and an average 1,200 articles published each year from the which department it is? Material science. See, we selected earlier this material science. Okay, if you select this material science, this is the publication pattern year-wise. Then author-wise also we can see this. Okay, who is the highest publisher? Who is the lowest publisher? So if you see this author pattern also, we can observe who is the unidentified one author is there. So Davidson is 58 articles. Who is the highest? Dressels MS 611 articles. Langer is 495 articles. This way we can apply bibliometrics to understand publications patterns. Meeku arthamainda? You understand, no? Can you hear me?
Yes, sir.
See, I shown an example how bibliometric study is practically we are using. See, bibliometric study, these are the statistical application patterns, publication patterns. Okay.
Okay.
We are observing with the year-wise, if you see, and open access model, what kind of open access model? Earlier also we studied gold, hybrid, bronze, and number of author-wise and subject-wise. Type of document also we can, articles, how many, conference paper, reviews, book chapter, letters, okay, source title, which journal they published. Most of the articles published in Proceedings of SPI, okay, the International Society for Optical Engineering. SPI means Society for International Optical Engineering. In this, they publish more number of articles. We can call it as zone 1 or zone 2, okay. Earlier also we did. Then remaining video will complete and we'll come back to this.
Okay, sir.
The data that I collect may be different from the data that Web of Science collect. Okay, because we have different coverage. All right. And the software code. A lot of the time, all of these things are crawled or managed by the software that they use. So it's also being controlled by the software itself. If the software doesn't have the capabilities to crawl that, to do that, they're not being connected or collected in the database. Okay, and it also has to do with data accuracy. I'm the author, okay. There are times I put in Yaling Lu with a hyphen. There are times the journal doesn't allow me to put a hyphen in the middle. There are times they only ask me to put first initial and last name without full name. So there are a lot of things that I do not have control over, okay? But there are also times it's the mistakes or the errors from the publisher or the database itself. When they scan things, things can go wrong. When they put in things manually, things can go wrong. When they change the subject headings or the subject categories, things can go wrong. So a lot of things can go wrong, okay, in the input stage here. So a lot of times it also requires the author awareness. You probably can't imagine how many times we have to talk to the investigators or researchers saying that although you're a senior already, please always state your affiliation. There are many times people just cite NIH without talking about they're from NIAID or NIAAA or NICSE because they're senior. They just do not care. They just put NIH. Sometimes I even saw senior authors just put in Bethesda, USA as a way to show their affiliation. Okay, everything. Okay, so if somebody says that I published a lot, or maybe, all right. Another thing is humanities, the citation rate is much slower than the rate in other sciences part. Okay, so this is the chart from Scopus. Okay, I want to give them the credit. Okay, so what they said is that they found that publication in neuroscience and life science have much higher rate of citation accumulation. And you can see the bottom is arts and humanities. Okay, so from the top is the one that has much more publication and much more citation at the bottom. They have fewer articles output, fewer citations. Okay, meaning that even if when you pull up full publications, okay, you just can't compare the raw citation because of the nature of it. All right. Another thing is about the citation distribution. Okay, citation distribution is not the normal distribution that we see in statistics. So when you see a normal distribution, it means that you can use average to represent a lot of things. Okay, so we talk about the average age, we talk about the average height on these two specifically, and I'll be talking more later in the weeks for other things. Okay, remember we talked about that citation distribution is not normal distribution, so you don't want to use the mean or average citation to describe a lot of things. Okay, so this is one thing that people used to, one mistake people used to make. They want to say that, okay, the average citation in our group is blah, 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 or the average citation of my publication is blah, blah, blah. Okay. The major mistake was that even within one office or one group, the publications can be very different, can cover different groups, different fields, different disciplines. And remember the chart from the Scopus, okay? Different fields have different rates of citation accumulation. It means that they're going to have different average. So you don't want to use that average. And even for that field, it's still not normal distribution. And you still can use that average. Okay, so this is one major mistake that people used to make. Okay, and as I mentioned, that citation rates are influenced by a lot of different things. Okay, the discipline, publication age, document type, size of the field, and also bias. Okay, there are a lot of times we just cited something that we know my mentor, my advisor told me to cite, or because she or he is my student, I want to promote her, so I cite her article. So there are a lot of bias. Sometimes we're aware of it, sometimes we're not aware of it. There are also times we think that he or she is my competitor, so I'm not going to cite his work at all. And it happens. It has been discussed. All right. So a lot of things that bias that we are aware or unaware, consciously or unconsciously, basic metrics such as journal impact factors as a surrogate measure of the quality of the individual research articles to assess an individual scientist's contribution or on hiring, promotion, or funding decisions. So this comes from the background that because so many people are using journal impact factors, they started asking researchers to put journal impact factors in their.
Yeah, one more example I would like to show here. 1 minute.
And I think
yeah, one more example for bibliometric study, we can use VOS Viewer is a one kind of open source tool. Okay, how the data collated and visualized. Okay, I would like to show one more VBD video here.
We want to visually represent the documents of 6 researchers who work on public health topics using a term co-occurrence network in Boxword. Today, we'll use publication data from Scopus, but for the term co-occurrence map, Boxviewer accepts data from Web of Science, Scopus, Dimensions, PubMed, and some others. And we'll discuss data sources near the end of today's class. So if you don't have access to you have, so with the viewer, we can now create our term co-occurrence map. In the Boxviewer window, be sure to select CSV as the export method and make sure you select citation information, bibliographic information, abstracts, and keywords, and include references. This information will give you a flexible data set from which you can create several types of maps in Boxviewer, beyond even in the term co-occurrence network that we're covering today. If you don't have access to Scopus and you want to use the same data set that we're using in today's class, you can download the data file from the box link that's provided on this slide, and it's a similar link to the box link that was provided in the chat and on Slack. So I'm actually going to go ahead and move away from my slides and open Scopus and just show you really quickly how you might get that data from Scopus. So I have Scopus open, and I'm going to navigate to the advanced section. I'm going to go ahead and copy in my author ICD first name for the authors that I'm interested in. Click on search. I got an error. I'm going to close Scopus and open it again from my library's website. Oh, there it is. There's my search. I'm in advanced. I'm going to search. Okay, so now I have the 624 documents that I am interested in from the 6 researchers that I mentioned. I could go ahead and refine those results, perhaps by year or document type, maybe even publication stage if I don't want any of those, early access articles in there. But I don't actually want to see everything in this analysis. And I'm going to go ahead and select all of the documents, all 624, and I'm going to export them. I will choose the CSV option. I will choose not only all the citation information, but all the bibliographical information, the abstract and keywords, and also include references. Like I said, this will give you the broadest data set to use from Scopus in Boxviewer and create other maps than just the term co-occurrence map. So then you go ahead and click export. And then you'll want to save that file somewhere where you remember that you can find it again, because we'll need to find it when you're in Boxviewer. And make sure you save it as a CSV. All right, so mine's going to open, but I already have it saved somewhere. So really back to my slides really quickly here. Wait, there we go. Okay, so actually the next step we're going to do is we're going to open Boxviewer. Let's close this. And I'm going to navigate to my Boxviewer and open it. It opened on my other screen, but there it is here for you. So this is actually as large as I can get Boxviewer. So I realize that some of these buttons are a little small, and I apologize for that. But I have tried to make my mouse a little bit bigger, so hopefully you can kind of see the general area in which my mouse is clicking as I go through. So I do have
yeah. This is the VOS Viewer is a software, open source software. You can also download it. Okay, you can download from Scopus data, and how visualization of bibliometric data, how it is going to be analyzed, how it is going to be create different kind of visual representation. That's what here I would like to show. Just we go through, and you can practically we can see tomorrow. Okay. We can see that how it is going to be downloaded from Scopus data, how we can import into the VOUR, and visualize the bibliometric data. Then you can understand what is the bibliometrics, what kind of different kind of bibliometrics data. This is say different kinds of laws are there. How we can apply that.
So with Viewer, we can now create our term co-occurrence map. In the Viewer window, if we look to the left, you can actually see under the info section that there is access to a manual. And this is really helpful. So a lot of the content for this presentation comes directly from this manual. And so I'm not going to be using slides directly for this portion. I'm going to be using Viewer, but please note that there's more information on my slides should you find that helpful, or you can go directly into the manual itself and use that. Okay, so to get started creating our map, we're going to go up to this map section and click on create. And that button brings up what's called the create map wizard. Apologize because everything is opening on my other screen, but I will just drag it over here as we go. So the very first thing we need to do is choose the type of data that we're working with. We are actually going to choose create map based on text data. Please note that Viewer assumes that the text data is going to be in English. And also note that creating maps using text data works best when we have data sets of about 100 or more. And that's just because larger data sets tend to yield more interesting maps. So if you have really small data sets, it's okay, you can still create a map. You're just going to notice that there aren't maybe a lot of terms that it's able to pull out. You might have to adjust some of the amount of terms that you allow in the map, which we will cover in the upcoming workflow. So bigger or larger data sets generally tend to yield more interesting results. We will briefly cover other types of data and maps available in Viewer, some of these other things that you see towards the end of the class. We're going to click next. So now we need to choose the data source, and we will choose read data from bibliographic databases. All right, bibliographic database files. So the supported file types are Web of Science, Scopus, Dimensions, and PubMed. And this is how now we are going to click next and then open that CSV that we saved from Scopus. So I'm choosing Scopus here, and then I'm going to go ahead and navigate to the Scopus file. So I have a little bit of navigation here to do. I'm going to pull this over so you can see. I'm just navigating to where I saved my file that I downloaded from Scopus. So here it is. You can name it whatever you like. So yours probably isn't named the same as mine. And then we're going to go ahead and click next. Now, if you were to try to upload this Scopus file under Web of Science or Dimensions or PubMed, you're going to get an error because Viewer is actually looking for very specific column headers that it will expect to see from Scopus or from Web of Science or Dimensions or PubMed. So you do need to make sure that you get this correct. If you don't, that's fine. Just start over, click on the database or the data, the database that you're using, and then move ahead. Okay, so we then need to choose the fields from which the terms will be extracted. We're going to choose title and abstract fields. These fields will then be concatenated or combined together to represent the text of a document. We will also keep checked ignore structured abstract labels so that those commonly used section labels for structured abstracts are going to be ignored. We are also going to keep checked ignore copyright statements. Really helpful because that's going to ignore those copyright statements that are often found at the end of abstracts. Okay, so then we're going to click next. So now it's extracting terms. I'm going to go through briefly what that means, but please note that you can refer to the manual and all of the references that they have provided to understand what it means to extract terms from a document set. So there are actually 5 steps that Viewer goes through to identify those terms. The first is they remove the copyright statement if you check that box in the workflow. Then it uses an algorithm from the Apache Open NLP library to do sentence detection. So it actually splits the data into sentences. Next is the parts of speech tagging. So again, uses an algorithm from that Apache Open NLP library to assign each word to a part of speech, such as this is a verb or a noun or an adjective or preposition and so on. Then there comes noun phrase identification. So a noun phrase is just a sequence of, and we have two options for choosing a you will create to help to be included in that. If you chose and the manual and the references provided for how that sort to consider recording the number of terms to be selected is highly accurate. But you are then searching for a shorter term in the sentence, and it's in merging or removing nodes if you want. So we'll discuss this later, but you can use it again to merge terms or remove specific terms altogether from your map. So we're going to click finish because now we actually have gotten to the end of this Create Map Wizard, and hopefully we will see our network. Awesome. Okay. So the first.
Yeah, this is the final output after downloading from the Scopus. See how it looks like. See.
Map that we see is called the network visualization. You can see that in the tab up here. Items are represented by their labels and also by a circle. The color represents the cluster to which the item belongs. You can see some different cluster colors here. You can review the manual for information about the clustering algorithm. The circle size is determined by the weight of the items. And we'll talk about all the different weights that are calculated in just a minute. The labels for some items may not be displayed to avoid overlapping labels. So that can be a bit difficult, but again, it's optimized for viewing. Lines between circles represent lines between or links between items. The thicker the line, the more often the terms are used together in the data set. The layout of the circles represents how related the items are. So the distance between two terms indicates how often they co-occur in the data set. So as you can imagine, the smaller the distance, the larger the number of co-occurrences, and the stronger the terms are related to each other. All right, so we are actually going to now talk about some changes that you can make to this. So we're going to look over here at this visualization box. So the scale slider, I'm just going to move that around so you can see some of the changes. Actually, here, you know, it's up to you to decide how this works. And so the average normalized number of citations received. So I encourage you to kind of play around with these different overlays. The one thing about the density overlay is that you can actually zoom or whatever, you can move things around. So the other thing to note in this item filter is
yeah. మీకు అర్థమైంది అనుకుంటాను how it represents publication details in a different visualization of the. Can you hear me? వినిపిస్తుందా?
Yes, sir.
This is the one example they taken from the Scopus data, publication data. Then they used the VOS viewer and show that how publication pattern, how they published in a different subject area, diabetic, biochemistry, biomedical, and different subject areas. They analyzed it based on the publication, right? These publication data can be useful with different kind of bibliometric laws. Different bibliometric laws ni oka Excel sheet lo తీసుకున్నటువంటి డేటాని ఎలా అప్లై చేసి విజువలైజ్ చేయొచ్చు, దాన్ని ఏ విధంగా యూజ్ చేసుకోవచ్చు అనేది ఒక బెస్ట్ ఎగ్జాంపుల్ అది. Then tomorrow we'll show with one example. Okay, you need to study each and every law, bibliometric law. మీరు రేపు చదువుకుని రాలి. So without studying the bibliometric laws, no, you cannot understand how it is going to applicable for the particular subject area. Okay. Tomorrow we'll discuss once again the same bibliometric law and citations. Okay. Now, chapter Unit 8, Bibliometrics and Allmetrics. Tomorrow we'll once again rediscuss on bibliometrics and application, limitations, what are the laws are available, how it is effective and what are the advantages, disadvantages of different clause, whether it is applicable present scenario, that also we'll discuss. Okay. Then we'll move to the altmetrics. Altmetrics is one kind of advanced area of analytics, bibliometric analytics. Okay. Then in last chapter, citation. Last chapter is citation and indexes. It's a very simple topic. Don't worry. And institutional repositories, 11th chapter. This I will show it to you practically. 11th, tomorrow is the last day, right? Repe kada last class nadi?
Yes,
Can you
sir.
take it? Kabatti, we don't have that much time. Okay. Tomorrow around 10 to 15%. Okay. 10 to 15%. We'll rediscuss on the cynometrics. Okay. Citation indexes. Okay. Then after that time, I would like to show institutional repository. Institutional repository ఎలా వర్క్ అవుతాయి ప్రాక్టికల్ గా ఒక ఎగ్జాంపుల్ మా స్టాఫ్ ఒకరు ప్రెజెంట్ చేస్తారు మీకు హౌ ఇట్ అప్లికేషన్ ఆఫ్ ఇన్స్టిట్యూషనల్ రిపాజిటరీ. ఓకే, టుమారో విల్ డిస్కస్ ఇన్ డీటెయిల్. ఎనీ డౌట్స్? రేపు టైం లేదు కాబట్టి రేపు ఓన్లీ వన్ క్లాస్ ఐ హ్యావ్. ఓకే, citation indexes, bibliometric studies అన్ని కూడా ఒక 10 to 15 minutes డిస్కస్ చేసేసి then we'll move to important topic, institutional repositories. Okay, let me know. Okay, మీకు ఏదైనా డౌట్స్ ఉంటే చెప్పండి. మీరు సైలెంట్గా ఉంటే అంత అర్థమైనట్టు. ఎవ్రీథింగ్ యూ అండర్స్టాండ్. మీకు అంతా తెలిసిపోయిందని చెప్పాలి.
కొంచెం స్లైడ్స్ కొన్ని అర్థమయ్యాయి, కొన్ని అర్థం కాదు.
ఏ స్లైడ్? నేను ప్రజెంట్ చేసిన స్లైడా లేదా ఈరోజు వీడియో చూపించిన స్లైడ్స్ అంటున్నారు?
ఈరోజు వీడియో చూపించిన స్లైడ్స్.
వెరీ సింపుల్. బిబ్లియోమెట్రిక్ కాన్సెప్ట్ మీరు అర్థం చేసుకోవాలి. ఫస్ట్ ఆఫ్ ఆల్ యూ నీడ్ టు రీడ్ అవుట్ ప్రాపర్లీ, చదువుకుని దాని బిబ్లియోమెట్రిక్స్ ని ఎలా అప్లై చేస్తాం లైబ్రరీ సైన్స్ లో. మీకు ఒక ఎగ్జాంపుల్ చూపించాను కదా, హౌ ఇట్ ఈస్ గోయింగ్ టు అప్లైడ్. ఓకే, ఆ డేటాని మన బిబ్లియోగ్రఫికల్ డేటాని తీసుకుని విజువలైజ్ చేసి ఎలా అనలైజ్ చేస్తారని మీరు చూసారు. I will once again project the same slide. Okay, 1 minute. See if possible.
The group items by cluster. So if it is checked, then the items are first grouped by their cluster and then listed alphabetically within their cluster. If unchecked, it just shows all items. Another thing to note is that when you are
ఈ స్లైడ్ అర్థం కాలేదు సార్.
ఈ స్లైడ్ ఏంటంటే బేస్డ్ ఆన్ ద స్కోపస్ నుంచి ఫస్ట్ డేటా డౌన్లోడ్ చేసాము. ఆ డౌన్లోడ్ చేసిన డేటాని విఓఎస్ వ్యూవర్ లో సాఫ్ట్వేర్ లో మనం ఇంపోర్ట్ చేసాం. సబ్జెక్ట్ టెర్మినాలజీ మధ్య ఉండే రిలేషన్షిప్ ఏంటి? వాట్ ఈస్ ద రిలేషన్షిప్ విత్ డయాబెటిక్? ఫర్ ఎగ్జాంపుల్ బాడీ మాస్ ఇండెక్స్, బిఎంఎస్. ఈ ఏరియాలో బాడీ మాస్ ఇండెక్స్ కి డయాబెటిక్స్ కి, తర్వాత ఇవన్నీ సబ్జెక్ట్ టెర్మినాలజీకి ఉండే రిలేషన్. ఎన్ని పబ్లికేషన్స్ ఉన్నాయి, డయాబెటిక్స్ ఎక్కువ పబ్లిష్ అయింది, బాడీ మాస్ ఇండెక్స్ ఎన్ని పబ్లిష్ అయ్యి, ఆ పబ్లికేషన్ టెర్మినాలజీకి ఉండేటువంటి రిలేషన్షిప్ ని చూపించే
డేటాబేస్ ఎట్లా ఎక్కువ చెప్తున్నా సార్, ఎట్లా పబ్లిష్ ఎక్కువగా ఉందని.
నెంబర్ ఆఫ్ టర్మ్స్ ఇట్ ఇస్ యూజ్డ్, రైట్? హౌ మెనీ టైమ్స్ ఇట్ ఇస్ కీవర్డ్స్. అబ్స్ట్రాక్ట్ లో ఉండేటువంటి కీవర్డ్స్ ని సాఫ్ట్వేర్ అనలైజ్ చేసింది. మీరు ఇంతకుముందు you need to properly okay, here ఇక్కడ చూడండి.
This is the export method, and make sure you select citation information, bibliographic information, abstracts, and keywords, and include references. This information will give you a flexible data set from which you can create several types of maps in BLISc.
ఇప్పుడు చూసారు కదా, ఇది స్కోపస్ నుంచి డేటా తీసుకున్నారు. they downloaded scopus data. Here keywords are there, bibliographical, abstract, and indexed references. Okay, indexed references.
Okay,
ఈ కీవర్డ్స్ అన్నిటిని బేస్ చేసుకుని ఇక్కడ సాఫ్ట్వేర్ లో డేటా అనలైజ్ చేయడం జరిగింది.
ఓకే
ఓకే, ప్రాక్టికల్ అప్లికేషన్ ఆఫ్ బిబ్లియోమెట్రిక్స్ ఎక్కడ ఇక్కడ ప్రాక్టికల్గా మనం అప్లై చేస్తే దీనివల్ల ఎలా యూజ్ ఉంటుంది చూడండి. ఇప్పుడు మనం అనలైజ్ చేయొచ్చు పబ్లికేషన్ అయినటువంటి డేటాను, పబ్లికేషన్ డేటాని బిబ్లియోమెట్రిక్ క్లాస్ అప్లై చేసి అనలైజ్ చేయొచ్చు. ప్రివెన్షన్, బేస్ లైన్, బాడీ మాస్ ఇండెక్స్, డయాబెటిక్స్, గ్లూకోజ్, ఓకే, హైపర్ టెన్షన్, కార్డియోవాస్కులర్ హెల్త్, పేషెంట్. ఇవన్నీ టెర్మినాలజీ మధ్య, అంటే ఈ టెర్మినాలజీ రిలేషన్షిప్ ఏంటి, ఆథర్స్ ఎంతమంది ఉన్నారు, ఏ ఆథర్ ఎక్కువ పబ్లిష్ చేశారు, దీనివల్ల ఈజీగా అర్థమవుతుంది. మనం ఇక్కడ నంబర్ ఏం తెలియట్లేదు. ఈ బబుల్ పెద్దగా ఉందంటే నంబర్ ఆఫ్ పబ్లికేషన్స్ ఆర్ మోర్, రైట్?
ఓకే ఓకే సార్.
యు అండర్స్టాండ్?
సార్ ఇందాక స్లైడ్ లో మనము కొన్ని ఆప్షన్స్ సెలెక్ట్ చేసుకున్నాం సార్ ఆరెంజ్ కలర్ తోటి. వాటిని బట్టి ఇది మ్యాప్ వస్తుందా సార్?
మ్యాప్ వస్తుంది, అది ఎగ్జాక్ట్లీ కరెక్ట్.
ఓకే ఓకే సార్. ఇందాక మనం ఆప్షన్స్ చూస్ చేసుకున్నాము. ఓకే.
హలో, కెన్ యూ హియర్ మీ? అర్థమైంది కదండి ఇది కాన్సెప్ట్?
ఓకే సార్, ఐ కెన్ అండర్స్టాండ్.
ఓకే. ఇంకా మీకు కొద్దిగా అడ్వాన్స్డ్గా వెళ్తే ఇక్కడ ఇంకా ఒక కాన్సెప్ట్ చూపిస్తాను. ఓకే.
On my map or whatever, for whatever reason, it just doesn't need to be there. So what I'm going to do is I'm going to show you, sorry, go back to my Slides here really quick. So I'm actually going to make a very simple thesaurus file, literally says label, and it says BMI, and replaced by body mass index. And so what that's actually telling Box Viewer is that I'm seeing this label BMI, and I would like to replace it by body mass index. And since body is legends, so we actually just went ahead and went into that map file. And like, for instance, we looked at the circle for participant. We drew a circle the size of participant and looked to see how many occurrences it had. And then we tried to find something that was like a medium amount of occurrences and find that and size the circle and then small. You have to be careful because now when you resize the map, you have to resize the circle so that it goes along with it. But it just helps the eye understand kind of what are we talking about here? How many terms? You can also do this for lines. We didn't in this case, but if you get some really thick lines in there and you want to show, for instance, two authors working together, you can do that. All right, I got a book because we're getting towards the end of this year. So there are other network and map types. So we have the co-authorship map. So these is where your nodes are going to be author names from documents in the data set, and your lines are going to be linking authors to a co-authored document. Again, make sure that you have those author lists in your data set so that Box Viewer can do this. A co-occurrence map. You can actually analyze, again, we did terms, but you can do keywords, author keywords, or index keywords. So your nodes then are going to be keywords pulled from the column of keywords that you gave it from like Scopus or Web of Science or what have you. And then the links are going to be keywords that have been used together in a document. Again, you have to have those keywords in there to do that in that data set. A citation map. You can analyze documents, sources, authors, organizations, countries. So if you're doing documents, the nodes are going to be documents from the data set, and the links, the lines are going to be linking documents from the data set that have been cited, that have cited each other. You have to have that cited reference in there though. Bibliographic coupling map, again, you can analyze documents, sources, authors, organizations, countries, but the documents, the nodes are going to be documents from that data set if you're analyzing the documents, and then the lines are going to be linked between documents that are based on the number of references they share in their reference list. Co-citation map, you can analyze cited references, cited sources, cited authors. Again, those nodes are going to be documents from the data set, and then the lines are going to link documents based on the number of times they're cited together on those reference lists. You can use a lot of different data sources depending on the map. So we've used Scopus, but you can see here different ways that you can use Web of Science, Dimensions, PubMed, Crossref, Europe PMC, Microsoft Academic, Semantic Scholar, Open Citations, Wikidata. There's a lot available to you. I will mention that there are some upcoming courses. There is a course called Bibliometric and Science Metrics for.
Yes. Yeah. ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా? Any doubts? Okay, tomorrow we'll get back once again. Okay, these are the bibliometrics, and in chapter 9, unit 9, citation indexes, bibliometrics and all metrics. All metrics we need to discuss tomorrow, and the citation indexes, and emerging trends in block 4, big data, institutional repository, e-resources, and challenges for libraries. Okay, tomorrow we'll club together and we'll get back. Okay, thank you. Okay, ఏదైనా డౌట్స్ ఉంటే చెప్పండి, then we'll close, otherwise we'll close. Okay.
Okay, thank you, sir.
Okay, thank you.
ఇది క్లాస్ హలో హలో క్లాస్ క్లోజ్ చేయమంటారా? అయిపోయిందా? క్లాస్ అయిపోయిందా?